My name is Sarah Jancic. I'm the tech director at Rep Equity, which is a digital branding firm here in DC.
Jeremy Gottwig. I'm a senior coder.
So I've been working with Drupal for about 6 years now. Started in the early days of Drupal 5 and looking forward to going to 8. Just like the rest of you, I'm sure. So today we're going to talk about a fairly young module called Search API. We'll talk a little bit about kind of its competitor modules as well. But just a quick note that it is a young module. It's only available in Drupal 7. It's maintained by a nice Austrian guy named Drunken Monkey. It is not terribly well documented yet, but he has actually put a lot of time into adding documentation in May and June of this year, so it's definitely getting better. Much of the documentation he's starting with is really geared towards site builders as opposed to developers, but I do think that he's making a lot of progress into documenting the API, so I expect that to get better. The original development was released, occurred in summer of 2010. It was part of a Google Summer of Code project, and his mentor was actually Robert Douglas, who's pretty well known in the Drupal community. And Robert Douglas was actually really involved in the Apache SSI module, to which Search API and Search API Solr are kind of competing modules in a way. There's definitely use cases for both, so we'll talk a little bit about that too today. The basic thinking behind Search API is that it was an abstraction module that gave you the UI within Drupal to set up a search index, but use a different backend. So in our case, we use the Solr backend, but there are other backends, including just the database backend that you could use. Another idea behind the module was that it was extensible, so there's lots of hooks written into it, so other developers can come in, hook into it how they need to really get custom functionality that meets the requirements. It also provides views integration, so search results are configurable and themable, which is very handy. And it also provides the ability to index entities, which we found very helpful in our most recent project. It depends on Entity API, of course. It makes use of the Entity Metadata module, which is bundled in with Entity API. You also have to have a backend module because Search API by itself just gives you a front end, but it doesn't actually talk to anything else. I think Solr is probably the one that's farthest along at this point, which it was also written by Drunken Monkey. But do note that Solr 4.3 isn't quite supported yet, but they're definitely working on it. It is completely possible to run Search API with just your database. It's not recommended, but you could do it if you just wanted to play around with the module and test it, or if you had a really small site in which speed or accuracy wasn't terribly important to you. You could also use MongoDB or some of these other search backends. Other developers are writing plugins to Search API to hook those backends up. So I haven't played around with a lot of those yet, so I don't know how far along they are, but do know that they exist.
If you want to get kind of a blow-by-blow between, should I pick Apache Solr Search Integration or Search API, I'm probably not going to give that to you necessarily. I think they're both good. We tested them both, although we kind of tested them concurrently for our specific use case, and which is not necessarily easy to do. And the reason why is because they use different Solr XML or schema XML files. So if you want to test them both, you're going to have to switch back and forth. I mean, if you're using the same Solr backend. But there are a number of key points here. The Solr Search Integration is really kind of intended, I think, to be a core search replacement. So kind of a drop-in where you install it, you connect your backend, and then you've got a search that works at, I think, search/site. Whereas when it comes to Search API, there is like a Search Pages module out there that you can use to kind of get more of an out-of-the-box core search replacement. But really, your best bet is to go to Views and to create your search through Views, which is really where the power is. So, and with our particular use case, we needed to use views in order to get the data returned from Solr that we needed in order to fulfill what the client was asking for. And we'll kind of, yes, sir.
Will Facet API work with views?
Yeah, absolutely. Facet API is something when you're installing the Search API module, it pretty much integrates right into it. So you can go ahead and create your facets right there, and then it just creates the blocks. Search API creates the blocks that you need, and then you just go ahead and dump it into your wherever you tell views to put your search page. So. They also return different things. I think this is kind of interesting. The SSI module will return. It tries to return content directly from Solr, which is great in one respect because it's going to be more of a lightweight module. I mean, I haven't benchmarked it or anything, but I would assume that since it's pulling data directly from Solr and giving you the content there, that which as opposed to Search API, which basically returns the node IDs and then performs an entity load on that. So that's more how it gets the data. So it's really tied into more the Drupal database, whereas the SSI module, it attempts to be more data agnostic. And then, of course, as Sarah already mentioned, the SSI module is more Solr only. So, I mean, it is Solr only. You're stuck. Whereas with Search API, you've got a number of backends you can use, which is great. We did some custom coding with Search API, and in theory, we should be able to go in and just drop in another backend, and all of our code should still work without really having to. So if someday MongoDB becomes the preferred indexer of choice or something like that, then we shouldn't have a problem migrating our stuff over. And the other thing, limited data control versus full control. Search API it gives you a nice form that allows you to go in and select what data you want indexed, and that includes data of related entities, which is great. So if you've got your taxonomy terms as well as just related nodes or something like that, you can go in and say, I want the taxonomy of this related node indexed, and it will actually get indexed with the entity that is being indexed. So we picked Search API because of that data control. Maybe possible to do some of this type of stuff with the SSI module as well, but if so, we didn't dig into it well enough to look at that. However, we really like the way that Search API did it, which is one reason why we ended up going that route. The view support's killer. Like I say, when it comes to our actual core search replacement, if we didn't have that view support, it wouldn't have worked. We could not have used the Apache Solr Search Integration module without a ton of customization for this particular project. And we like the query syntax. It was I found the Search API's query syntax to be maybe a little bit more like the Drupal's dynamic queries. For just like doing a database query. Pretty simple, easy to use. I think that the SSI query syntax is maybe a little bit more, I don't know, complicated. I don't know. It's just a personal thing. And the philosophy, being able to switch out the backends is great, and hopefully it'll work okay if you decide you ever need to do that.
So here's a list of optional modules that can extend Search API that are all available now. Of course, we talked about faceting already. So if you do use faceting, we recommend the pre-facet pass module because it saves the state of the search a little bit better. Also, search views, search sorts, search pages, save searches, all these are available now to kind of enhance the search experience on your site. One thing I will point out, though, is we had a little bit of trouble getting Search API more like this to work. So I don't know if that's come along. We were using it in the spring. Maybe it's come along a little bit more. But that was something that I think we had to do some customization to.
For which one?
For MLT, more like this. So these are the basic steps for installing Search API Solr. This assumes that you have already got your Solr server up and running. You just go into the UI and create a new server, and then you create an index associated with that server. And then you select which fields you want to index and configure each's data type. So they can be string, full text, etc. You can apply any index time boosts if you want. They're very limited in the UI right now. there's only a few data types that actually support them, so that's something to note. And then you can select any data alterations that you want. For example, the bundle filter allows you to exclude content types. You can use the node access filter to attach access permissions inside the index. And then, of course, the exclude unpublished nodes filter does exactly as it sounds like. And then I've included a link here. There's some great step-by-step instructions available online on with screen grabs of exactly how to get started. So under the hood, this is kind of how it works. So it sends things to, out of the box, I think it sends things to Solr on cron jobs. So when you update a node or create a node or delete a node, it actually tracks that in a Search API table with either a timestamp. And on the next cron run, it takes everything with a timestamp and sends it to a Drupal processing queue. It does send them in batches that you can configure inside the UI, and then Drupal will use its queuing API in order to process them. One thing to note is that just because Drupal sends this to Solr doesn't mean it's automatically in the index. Solr auto commits after 120 seconds or 10,000 documents, whichever happens first. So there is a bit of latency. Your watchdog will tell you that Solr successfully indexed it, but it may not be available yet. So that just means that the handoff from Drupal to Solr happened successfully, not necessarily that Solr put it in its index yet. So just a quick note that index time and query time boosts are available within this module. Some through the UI, the index time boosts through the UI, query time boosts through code. You can also add index time boosts in the field definitions of your schema.xml file. Search API comes with a couple XML files that you actually have to put into Solr. And it does it dynamically. It has like dynamic fields. That's how it kind of works with the UI. So it can be a little bit difficult to add boosts, but if you really needed to do it, you could. And then there's a hook available for query time boosts, which I've put here. And then I just put a couple examples because I had to do this, and there were like literally no examples online how to do it, and I'm trying to save the next person some time. So the first one is a boost function. So basically you're running a function. It's going to return a value, and then that gets added to the relevancy score that Solr keeps. So in this case, I'm giving extra weight to recent content, and then over time, the extra weight decreases. So if it's brand new, it gets a really big boost, and if it's 6 months old, it gets a much smaller boost.
So this adds it to the actual configured boost level.
Yes.
It just degrades down to that.
Right. Yeah. Unfortunately, you have to do this in code right now, but yeah, this is the way to do it. So the next kind is a boost query, and this is just like straight up, I want to take the relevancy score and times it by a value. So in this case, I'm working with a Boolean. So if the Boolean is true, I want to times it by 100, the boost score, or the relevancy score, and if it's false, I don't want to do any boost at all. So those are kind of the two query time boosts that you can add in code. I just popped this into a custom module. As Jeremy said, in theory, if we switch backends, I don't know what would happen.
That's not going to work.
Oh, okay, it wouldn't work,
no.
but just that's an example of one of the hooks that I think would probably get used the most. A few gotchas. So because Search API is trying to be a one-size-fits-all for a bunch of different backends, there are configuration options in there that don't make sense with your backend. So there are a lot of options, for example, for preprocessors that you don't need to use for Solr because Solr already handles it. So in some cases, it doesn't necessarily hurt anything. In some cases, it is going to give you wonky results. The HTML filtering you should use in Solr, especially if you're using full text fields and you're sending HTML as part of that to the indexer. But definitely one of the gotchas that I ran into was don't use the ignore case filter, because if people search on your site with a term that is all lowercase, and all the excerpts that come back, it's going to be in all lowercase too. So it won't use the case that was actually indexed with it. So it's not going to break your site, it just looks kind of wonky. So as I mentioned before, there is a bit of latency, between when Drupal makes the handoff to Solr and when the document is actually available to Drupal within the search results. There is an option within Search API to index immediately, which would bypass the queue, the Drupal's queue system. And this would be, I think, appropriate for a smaller site that was only running cron, maybe hourly, and they wanted their documents available in the search very quickly. But for a large site, that's a really good way to cause performance problems. So
we tried it.
Indexing large sites definitely can hog memory. So this is definitely getting better, but we were working with some of the release candidates. Like I said, the first stable release just came out in, I think, like the last month. And we were trying to index a site with 2 million nodes, and it did not go well. So what they've done in the stable release is before in the release candidates, they were sending batches to the queue UI, but putting it in the same queue. So if your queue died, you were kind of sunk. In the stable release, they're actually making little queues of each batch size. So if you lose one queue, maybe 125 documents aren't going to be in your index, but that's not the end of the world. At least it's not like totally killing your site. Because if you get a dead queue, it kills all the other queues that come behind it too, unless you clear out your queue table. So as I mentioned before, there are limited index time boosts available, but I think that support for that is going to get better. And I guess the number one gotcha is when you first turn on Search API and Search API Solr, you are like, great, here we go, but there's like no UI for your interface. So you actually have to use views or search pages to actually have a search that you can put within your theme. So our use case was a very, very large news aggregation site. It's populated by an API. They publish about 1,300 nodes a day between the hours of roughly 6 a.m. and maybe 3 p.m. They had extremely complex rules in terms of what content was supposed to go where. That was part taxonomy driven and part field value driven. We had very complex content types with lots of entity references, including a two-dimensional taxonomy system, and we put it all on a MySQL database. So we were very concerned about how we were going to actually be able to pull this off. We knew core search was completely out of the question, so this is how we used Solr.
And real quick too, there's a module out there that I think ended up being rather indispensable for us for kind of monitoring some of these like Search API breakdowns and things like that. It was the Q monitor. What was it?
It's the QUI module.
The QUI module. Yeah, it's really worth checking out. It gives you a real sense of what actually is going on in Drupal's backend when it's right. I think it's in dev at this point, so I don't know how. I don't know. It depends on how you feel about deploying dev stuff on your site. But it's really indispensable for us. But anyway, so we use Solr in 3 different ways on this site. Our taxonomy pages were all kind of this, we call them portal pages, and they were this, basically what we had going on was on each taxonomy page, we were running a query that would provide us with up-to-date data from this API that we were grabbing. And there are a number of kind of criteria that made it very challenging, which I'll get into in a second. And for that, we ended up having to, I guess, kind of roll our own custom Search API query. Couldn't use views. And I tried. I don't know if Sarah remembers this, but I remember back in the early days, I sent her probably a number of emails, excited about, I'm sure we can do this with Search API using views. And then eventually I was just kind of like, no, I'm just going to custom it after, I don't know, a week or so. Maybe not quite that long. The more like this blocks, we used Solr for that, but we did not go through Search API. And like Sarah said, it was because we ended up having some problems with views at the time, and in fact, even running a custom query with that didn't seem to be working right. Maybe it works better now. I don't know. And then our actual search itself, our core search replacement, is using views with the Search API. But I want to talk primarily about the taxonomy pages. So, as I say, we have our taxonomy pages with up-to-date API content. So the stuff that comes through, we pretty much want it to be displayed on the site almost as quickly as possible. And where it gets tricky is that each piece of content has a UUID, which is something that the API itself provides. And actually it has two UUIDs. It has its own UUID, and then it also has a parent UUID. And we might, let's say we might at any given time be displaying, I don't know, I'll say 35 items on a single page. We need to make sure that those that each UID shows up once and only once. So somehow we have to create a filter that will prevent basically prevent that from not happening. So the UUID has to show up once, and the same thing goes with the root UUID. And then of course this will involve several unique queries on each page, which makes it difficult too, because if you had multiple views on a single page, getting them to share that kind of UUID information, I don't know. So we ended up, it might be possible, but honestly it would have taken a lot less time just to custom something up. So which is what we ended up doing. And I'm going to give you kind of a very simple sense of how to use the Search API's query syntax for generating some sort of a custom page. So like I say, it has a query syntax reminiscent of the dynamic queries. It's not the same, but it feels similar. What it does for us is, in creating these custom queries, it does allow us to add a bit of additional processing for the page, so that we can do things like make sure that UUID only shows up once. And then another thing too is we had articles with formats, something we call formats, which is something else that's provided by the API. And there are also a number of formats that we need to make sure don't actually show up on the page at all. That's something we could have done with views, but it was relatively easy just doing a custom query like this. Here's a very simple example. You could, using what we have right here, you could basically create your own, I guess, core search replacement page almost. First line there, query, search API query. The Solr is the actual index name, which is something that you define in the Search UI interface. Status true equals, that probably looks fairly familiar to you. That just makes sure that you're pulling published nodes. Body value null, make sure that you've got a body that actually has content in it. For us, we wanted to make sure that every item that came through actually had something to display. It wasn't, and in this API, we did get a number of nodes that would come through with no body at all. So they didn't want that stuff to show up, and for good reason. Here's something we did not use, but you can query keys. So there's your search terms. And then, of course, you've got your range and your sort. Pretty simple stuff. But anyway, once you execute that, you're going to get a nice big blah of stuff that you can go through and do something with. So it's I believe it just kicks back an array. So, but you can, if you're at all familiar with the Lucene query language, really what we're doing here is we're just using Search API's functions to create a Lucene query string. And so what that allows us to do, what Search API allows us to do, is create more complicated Lucene's query strings by creating multiple filters. So here, if you take a look at what we've got the filter query, create filter, and then we've got a new filter object that we can work with, and then you eventually merge it back into the main Search API query. And if you were to take a look at the actual output of that, it's just going to look like a Lucene query that has all of your Boolean functions and what have you built into it. Pretty simple stuff. The only like I say, it's the reason why it's not like Drupal's dynamic queries is just simply because Lucene operates differently.
Yeah, for example, you can't do group by. So, which would have been very handy for us in our particular use case, but was not available.
Yeah, and you know, Solr does support. We didn't use it, but Solr does support some group stuff. But you know, at the time that we were doing this, it was not supported in the Search API Solr module. So just a few things to remember is you've got all these subfields that you want to work with. So if you want to query a link field in Drupal, you need to make sure that you know what your subfields are. So here we've got, you know, field publication colon URL and, you know, colon title. So if you wanted to query by the title, you could do that using this. If you're storing related entity fields, you can filter by those as well using the little thing you see right here, where it's just, you know, status just is you know, field related field colon status, you know, equals 1. So now you're returning, or I guess you could say true. Now you're returning published nodes. Now you're returning nodes in which the related field is published. So, and you could do the same thing with the related fields taxonomy, which is something we had to do quite heavily. And the reason why we had to do that is because in our case, the taxonomy was not actually, the taxonomy terms that we were filtering by weren't actually part of that node. They were part of the related fields node, which, you know, was a little bit mind-blowing at first. But that's how we had to build the site. And the Search API response does include all the faceting information for that search. We didn't use that, but it is there if you wanted to use it. And cache, I just wrote this line in here. You do want to make sure you've got some sort of a good caching solution here, because, like I say, these are our taxonomy pages. So these are pages with content that people go to, and because the Solr is sitting somewhere else out there in the cloud somewhere, if for some reason that got severed, we of course would have a problem with our taxonomy pages just not working. And we built it in such a way where it kind of had a slightly graceful fallback. At least you would see something. You're not going to get a weird white screen or something. But if you're not caching, you run the risk of your Solr backend going down and your website not displaying things. So yeah, make sure you're running Varnish or something like that. Varnish probably.
So how often the cache should be cleared?
How often are we clearing
Well,
it?
and on our particular case, we're caching for 15 minutes. So we're using Varnish, and then we're also using the Drupal's page, like its core caching. The thought behind that was just insurance, basically. If Varnish failed for whatever reason, we didn't want to be completely uncached when people started hitting the web server, because it would have just blown up. So that's why we decided to use both, and we did 15 minutes in both cases. So with that, no hard questions allowed. But if anyone has any questions, we'll be happy to answer them. Maybe.
Just a related field. I just don't know what that's all about.
Oh, so it's actually like an entity reference field. It's just a field type that you can put into your content type.
Okay.
And so in our case, because our taxonomy terms were 2 nodes separated from the actual articles that we were dealing with, we were storing the related brief that had the taxonomy with the article. And so then when we went to query it, we had to query off that related entity. If that makes sense.
It's a beauty that Search API lets you do that too, because if it didn't, we were going to have, in order to create these taxonomy pages, we were going to have to make some, I think, kind of crazy queries directly into the database itself, with all kinds of crazy joins, and I mean, it would have been, I think it would have really been a mess. But the nice thing about the Search API is because you can index those related fields, you can just run a single query based on those related fields, and you don't have to do any additional, MySQL query, gigantic dynamic query that just would have been a mess to make work and make efficient.
Yes.
Do you all play with the, I think it's called Search API multiple entities or something like that? Allows you to query multiple entity types, single query.
No.
As in nodes, taxonomy terms, or users, or whatever.
Oh. We didn't actually have to use it on this particular project, but it is definitely possible.
Yeah, it's possible, but
is it still kind of buggy?
against
Yeah.
It's because it blows out the facets, especially
does it?
maybe not your core facets, but when you start adding facets like date facets, file facets, it can do some really funky stuff.
Yeah. Yeah.
So I was curious if you had any experience with that. Or...
Yeah, we didn't try that for this project.
Yeah, luckily for our site, there are no authenticated users other than administrators, so we had no need to really search users or anything like that.
We had taxonomy terms because now you can field everything in Drupal 7.
Right.
So people are turning taxonomy terms into content that needed to be searchable, which is...
Oh, I see what you're saying. Yeah. Yes.
I used Search API about a year and change ago, and I was just wondering about some quirks that may have gotten better or not. I was going to see if they had. I found a lot of quirkiness in UI with like having to go back to your selected fields page and like save it, even though nothing really changed. If you change some setting on the next page, I don't know. There's just like some wonkiness in selecting your fields that you have to index.
I did not experience that, but one thing that they don't really warn you about is if you've already indexed your entire site, all 2 million nodes, if you go in and monkey with any of those fields, it kicks off a reindex. So
even if you don't change anything, if you just go down and hit save.
So there's no confirmation
Sucks.
or anything. So, and there's also no way to undo it. So yeah, and in our case, you know, a reindex of 2 million nodes takes about 2 days. So.
And it's interesting too because one reason why I bring up that Q UI thing is we were having a problem where because it was indexing so much at once, sometimes we actually were running into PHP memory errors, and when that would happen, it would double. I don't know why it would do this, but it would double the number of Q instances that it was trying to to index.
The number of items in the queue would be like double the number of nodes on the entire site.
Yeah, it would just keep doubling and doubling and doubling, and so we had, and this is the thing, is we would have like 1 million queue items, which each of those would have about 70 nodes that it needed to index. So it was just gigantic. So yeah, careful.
Yeah, but like I said, in the stable release, that's much better because instead of making one ginormous queue, they're breaking it up into little queues, and you can configure how many stories are going to be, or how many nodes are going to be in each batch that gets sent. We didn't have much luck going with batch sizes above like 125. So most of the time we were doing like 75 just to keep our PHP memory limit from blowing out. So, yeah. Yes.
Were there any specific field formats that you had a lot more work to do around? I worked with Apache Solr Integration mostly. For example, like date field issues sometimes.
Yeah.
Updates. You had that kind of challenges with specific file formats.
I don't think so.
I think the date. It was. I think with the date fields, it's just in Solr. It's just stored. I mean, I don't remember for sure, but I think it's just stored as just a timestamp. So if you're working primarily in timestamps, I don't think it should. I don't think it should be treated too much like any other field. Maybe I don't know for sure though. It's been a while since I've looked at that, but we have had to mess with dates a little bit. But I don't think we had too much problem with them, just because you send a timestamp and you get back stuff that after that timestamp or whatever it is that you were looking for. So, but yeah, one thing that's interesting is make sure that you take a look at your schema, because sometimes, especially if you're going to, or the Search API schema, sometimes, especially if you ever have to like query directly, the way it uses dynamic fields in the actual schema itself, so you need to know what those dynamic fields actually are. And sometimes, even aside from that, you're going to learn some very interesting things about how Search API is indexing stuff just by taking a really close look at the schema and how that works. And also the data, in the database itself, if you take a look at how the individual field table is, I think sometimes you can get the subfield that you might want to query on based on that, because it's always like value format and all that type of stuff. So that might help you out too, I think.
All right.
that's it. So thank you guys.